whenever we find this kind of problems, we need to be very, very careful on how to solve them because, well, we're told that first of all, we need to notice that we're given the static coefficient and the kinetic coefficient, okay? So those coefficients should like ring a bell on us and tell us that we need to find something else. And well, that something is that we know that um, we need to know how big should the tension be such that this sled moves, and well, and according to that tension, now we can know if we need to use the static or kinetic coefficient for the settling our equations. Okay, so first thing to do here is, dude, you need to know how big should the tension be, okay, such that the sled moves. For finding that, we need to find a point in which it is in balance. So I need to write my free body diagram well over here and here, and this is gonna be like, no, sorry. Let me just erase that. I screwed that. Nope, this is not this one. So I'm gonna have a tension here that's gonna have a 40 degrees with the horizontal, and I'm gonna have the friction force right over here. It's gonna be the tension. This is gonna be the normal force, and this is gonna be the weight. Okay, so I need to settle the equations for x and for y. So the equations for x are gonna be the tension cosine of 40 minus the friction force static because it's not gonna move, and it's gonna be equal to 0 because I want to know which is the minimum force for it to like stay on the same side, well, the maximum, sorry. And for y, I've got the normal force and plus the tension sine of 40, and this is gonna be minus the weight, and it's gonna be equal to 0. Okay, so we shouldn't forget about that. Okay, and well, from there we can just like, well, we need to remember that we need to find the force, okay, or this tension. It's gonna be this one over here. Now, how can I find that stuff? Well, that's gonna be a little bit complicated. Well, we need to do a lot of math to get to it. So I know that the normal force, the friction force, sorry, static one, should be equal to the normal force times a coefficient. Okay, so I need to find the normal force. Normal force can be gotten from the second equation, that's the equation on y. So I just know that the normal force is going to be equal to the weight, that's mass times gravity, minus t sine of 40 degrees. Okay, so from there, I just can get into tension cosine of 40 is going to be equal to mu s times mass times gravity minus t sine of 40 degrees. Okay, so from here I need to solve for t, and I'm going to find that t cosine of 40 plus mu sine of 40 degrees too. It's going to be equal to mu s, yep, mass times gravity. Okay, so from here I just need to solve for t, and that t is going to be mu s mass times gravity over the cosine of 40 plus mu sine of 40. Okay, and if I substitute all the values into here, I'm just gonna get that this is 0.2, the mass is 50, the the gravity is 9.81 over the cosine of 40 plus 0.2 sine of 40. Okay, and this, after I do a whole bunch of calculations, I'm gonna know it's 109.65 newtons. Okay, so up to this point I haven't solved a thing. Okay, but I know I need 110 more or less newtons to move this stuff. So I know now that this guy won't move my sled, but this guy over here is gonna move my sled. Okay, so let's keep on working with that. Okay, I'm gonna change the slide because I don't want to erase anything. So I'm gonna get a white slide for this. So, I need to find I need to find the friction force. Okay, so how to do this stuff? So when the tension is here, for the first tension is 100 newtons. Okay, we know that the sled is not gonna move, so we just can write this free body diagram once again. I just screwed it once again. Sorry, I'm getting used to screwing things up. Here we have this tension going up, the weight going down, and that going all in place. Okay, so there. Okay, now we need to know the friction force. So this is the normal force, this is the tension, this is the weight, and this is the friction force, and this is 40 degrees. Okay, so we need to do the sum of all the forces going on in X, and well, from here I can notice that, well, it's T cosine of 40 minus the friction force, and that thing is not gonna move, so it's gonna be equal to 0, and the forces in Y are gonna be the normal force plus the T sine of 40 minus the weight, and that's gonna be equal to 0. Okay, so I'm asked to find like the friction force, and the thing is, it's not gonna be that easy to find. Okay, so what should I do first? I need to find well, I notice that the friction force is like here, and I know T, and I know which the cosine of 40 is, so that's gonna be a little bit more easier for me to find. Yep. So from here, I just noticed that, well, the friction force. No, sorry, I'm just checking if I haven't screwed anything up. No, actually no. So this is gonna be the static friction force is gonna be T, that's gonna be 100 cosine of 40. And this thing, if I'm not wrong, should be 61.07 newtons. Okay, so this is the first result that we have whenever the tension is 100 newtons. Now, what happens when I have a tension of 140 newtons? Okay, so well, the free body diagram is going to be exactly the same. I just need to change the equation. So I'm going to have the friction force in X. Well, the sum of all the forces in X are going to be the tension cosine of 40 minus the kinetic friction. This is static. And that's going to be equal to mass times acceleration. Okay. And well, the forces in Y are going to be equal to, well, the normal force plus the tension sine of 40 minus the weight, that's going to be equal to 0. Okay, so first, once again, the recipe. I need to find first I need to know this acceleration for then finding this whole friction force. So well, it's gonna be a little bit like pain in the ass, but it's necessary. I know that the normal force is gonna be equal to the weight, that's mass times gravity, minus the tension sine of 40, and yeah, that's it. Well, I'm gonna leave it in letters because it's far much easier for us. It will be later on. And well, there I know that the tension cosine of 40 minus mu k times mass times gravity minus t sine of 40 gonna be equal to mass times acceleration. So from there, I just need to solve for a. So I'm gonna be left with a. It's equal to, well, it's gonna be huge. T cosine of 40 minus mu k mass times gravity minus t sine of 40. All of this goes over the mass, which I know already. So I'm just gonna be left with the acceleration is gonna be 0.943 meters over second squared. Okay, so here, from here, I can just plug this value in this equation and solve for Fk. Okay, so Fk, it's gonna be equal to, well, the tension cosine of 40 minus mass times acceleration. And if I substitute all those values over there, I'm just gonna be left with how much is it? 61.07. I'm sorry, I screwed this thing up here. That should be here. This guy over here should be 76.8.